So today we are going to talk about reasonable domain, but we're also going to talk in, sort of tie in some things with it being a correct domain, okay? And that piece is very similar to what we did in the POD. So that's the piece that we sort of already know of. How can we check and see if all the pieces we're talking about are right or if they're not, right? Could we have made mistakes? Could we see if we have things wrong in there? The newer piece is that whether or not it's a reasonable domain. So that's the piece we're going to sort of look at with notes today. Actually, I should say reasonable domain or range. Okay, so just because we know words and we know what these words up here mean, anybody want to take a guess at what we're doing today? What does that topic and or title seem like we're going to be talking about?
Domain and ranges.
Okay, so domain and ranges. What are domain and ranges? X and Y values. So we're going to be talking about input values and output values.
Captain Obvious.
And what else? What about those domain and ranges? Whether or not they're reasonable. What does the word reasonable mean?
Makes sense.
Okay, that they
Simple.
make sense. Are they values that make sense? Because the reality is I've just been giving you these random function rules that I just pulled out of my head. Right? In a few situations we've been tying them to things, right? But it's sort of just been like, ooh, let's get some random values. That's not realistically always the case. Right? No one's going to come up to you on the road and say, oh, Chloe, I'm thinking of the function y equals 2x plus 4. Would you like to give me some different representations of that? Chloe's going to look at me like I'm a crazy person and be like, no, and walk away, right? Because that's what I would do to a person. Okay, so instead what we're talking about is what's reasonable or realistic given the situation that we're in. So for example, let's go back to that problem that we've sort of been talking about at multiple points of saying we are going to sell flowers. I forget the exact value, but let's say for $4 each. And you're gonna need a vase for $9. That's a terrible 9. Pretend. 9. Does that even count as a sentence? I don't even know if that gets a period. Whatever. We have learned enough that we said we could then write this as a function rule. Right? We talked about taking story problems and turning them into function rules. So we're selling flowers for $4 each, and when you buy those flowers, you're going to need a vase to put them in that costs $9. Okay, so what are we going to write if we want to represent this as a function rule? What's that function going to look like?
F of X.
Okay, so f of x is a fine one. We could say y, but f of x is fine. F of x equals what? 4x plus 9, right? This is a total story problem, right? We're adding up the two things that we have to purchase. And because the $4 is happening per flowers, it gets a variable. Look at how quickly you all just did that and agreed with it and had no problems. And remember where you were at the start of the trimester? If I wrote that on the board, you all just went, ugh. And like, wouldn't even think about how to do it. Right? And your brain was just like, oh, I want to put f of x equals 4x plus 9. Right? Pat yourself on the back. We're making progress. We're doing great. Okay, so we can then make a table. We can plug in input values. We can talk about a domain and range. But there's going to be more input values that are reasonable than values that, and some values that aren't reasonable. Okay, so for example, Vida, how many flowers do you want to buy? 2. Vida's buying 2 flowers. Okay, so if Vida buys 2 flowers, how much is she going to pay? Well, 2 times 4, right? So 4 times 2 plus 9. So 8 plus 9 is 17. Brayden, how many flowers do you want to buy?
4.
4. Brayden's going to buy 4. So now we'll have 4 times 4 plus 9. So 16 plus 9 will be 25. Lindsay, how many flowers do you want to buy?
6.
6? 4 times 6 plus 9.
Big ribbons.
So 24 plus 9, we're going to have 33. Anybody a non-flower buyer in here? I'm really a non-flower buyer. Jesus, how many flowers are you going to buy?
25. 7.
No, you're a non-flower buyer. How many flowers are you going to buy, Jesus?
None.
0. Jesus is going to buy 0 flowers.
What's the...
Okay, so Jesus is going to buy 0 flowers. That gives us an output of 9.
Why if he's not buying flowers?
Right, okay, so some of this starts to get a little bit ridiculous, right? If he's not buying any flowers, why in the world is he having to pay $9? That sounds a little bit goofy.
I'm just buying a vase.
He's just, okay,
I'm just gonna throw it.
I'm really anti-flower buyer.
Maybe he already has flowers at home.
-2. I'm gonna buy -3 flowers.
How's that even
Okay, are we starting to get that it's not perfect in every situation? Okay, this is where we want to talk about what's reasonable. What is a reasonable domain? Is it possible for me to plug in an x value of 0 and to plug in an x value of -3? Well, absolutely, right? I mathematically can do them. There's no math limitations to me doing it. But does it make sense for the situation that we're talking about? Does it make sense for you to say, yep, Jesus, you owe my flower shop $9 because you bought no flowers? Well, no, right? That's not a realistic situation. So we want to set some limits of what's reasonable based on the situation that we're given. Okay, and here's the deal. I'm going to tell you right now up front, I'm not going to be giving you a bunch of test problems about reasonable domain. Because my goal is not for you to just go, oh, yep, I can find a reasonable domain and I can repeat the process Mrs. McKinney told me. Remember, our umbrella topic for all of algebra is functions. Okay, and so instead what I want you to be able to do is be a good critical thinker. Can I think about what is reasonable for me to do given this situation? And that's going to start to spill over in problems we look at later in the year. Okay, yes, my math is telling me that when I plug in 0, I get out 9. But my brain is telling me that Jesus does not have to pay $9. Okay, that's the critical thinking piece. I don't need Jesus to pay $9. He didn't buy any flowers.
I'm broke.
So there's a couple ways that we can represent reasonable domains, and we can talk about them. I am not going to force a specific way of you writing them. I want you to see some different options so that you know what those look like, and so that you could see them and read them and know what they mean. But again, this isn't like that, oh my gosh, you have 40 problems on a test and you need to be able to get an answer out. Okay? So let's use our brains here about what are reasonable input values. Is input X or Y?
Input X.
X. So what are reasonable values to get as an input value?
1 or above.
1 or above. Okay, so what we just said is that it's reasonable for my domain to be X values that are greater than or equal to 1. Would we agree with that statement?
Yeah.
We list a domain in braces.
We ever have
I think I could be a little bit more specific with how I wanted to list that domain. What type of numbers are greater than 1? An infinite, like what? 2.
3, 4, 5, 6, 7, 8, 9.
Okay, but what about like 7.4?
Yeah. Oh,
Can I buy 7.4 flowers?
No.
Ooh. So x being greater than or equal to 1, okay, but could we maybe be a little bit more specific?
Oh wait, real?
Okay, so you're on the right track. That's a really good track.
I got this.
Real numbers include positives and negatives, fractions, and decimals. Okay, Braden, what are you looking for? Let's see if
No, these are actually one of the pages that fell out of my notes.
Yeah, what page are you looking for?
The one where like we have like different types of numbers, like real numbers.
Oh, so Braden's looking for his number sets.
Integers.
Integers. What type of numbers are integers?
Totally.
Positives and negatives. Do we want negatives?
No, no.
Okay, what other number sets do we got?
Like rationals.
Irrational, real,
It's whole.
whole, and
Whole numbers are what?
positive.
Positive numbers including 0.
Oh. So.
Oh yeah, we can't do that because
Natural.
That's the what I said. Oh, I didn't hear you,
Did you
Lyda.
say neutral?
I said
Neutrals and natural. Neutrals. One of the things.
okay, so a better way to talk about our domain would be our natural number set. All natural numbers. Okay, so remember when we learned number sets, I told you number sets on their own aren't really necessarily the important piece. It's a way to give us a more specific answer without having to be on every number, not including fractions or decimals or negatives. Right? This sums it all up in one piece. Are we okay with that? So our domain is our natural numbers. Let's see if we can talk about what our range is. What's our range going to be?
The f of x values, or well, y, right?
Right, so in this case we could say y, that's okay. And what type of values can our range be?
17, 25, 30. Oh wait.
Wait, what do you mean?
What type of values can we get out?
You can get out anything. You can get anything. You can
Yeah,
get
really.
Can you?
No.
Well, I mean, you plug in a number. And
I mean, mathematically speaking, I can get anything out. Is it reasonable
No.
for me to get out an answer of 9?
No.
No, because that would mean you buy 0 flowers, which means you wouldn't be buying a vase to start with. So what would be the first amount that would be reasonable to get?
1.
Plugging in 1.
Wait.
If you buy 1 flower, that's the smallest number of flowers we could buy. If we buy 1 flower, how much is it going to cost us?
Wait.
$4.
$4. Yeah.
No.
No, plus 9.
Plus 9,
13.
$13. So what's the smallest amount you're going to be able to spend at my flower shop? $13. So what's the smallest Y value we're going to get?
Y is
Less
yeah,
than 30.
greater than or equal to 30.
Greater than or equal to $13?
Wait, why isn't it less than?
Because that would be numbers like 12, 11, 10, 9, 8,
Oh.
7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, -4.
Okay.
Wouldn't it just be 13 because it's the smallest you can go?
So 13 is the smallest you can go, so we can go greater than or equal to 13. But can we, like, what type of numbers are greater than 13?
Oh, you mean like one?
I mean, 14 is. Am I ever going to spend $14 at my flower shop?
No.
No. Am I going to spend $15 at my flower shop?
No.
No. Am I going to spend 16?
No.
Am I going to spend 17?
Yes.
Sure am. Am I going to spend 18?
No.
19?
No.
20?
No.
21?
Yeah.
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 That would be if I buy 3 flowers. 22?
No.
23?
No.
24? 25?
Yes.
Yup. 26?
No.
27?
No.
28? 29?
Yeah.
Okay, so what's happening? How are we knowing when to say yes?
How many
When
flowers?
the
Counted by
Wait,
four.
there's like a
Ah, right?
pattern
Oh,
of 4, yeah. Why did I say 3?
3.
Why did I say 3?
We don't have any magical number set here that helps us out.
7.
Okay, so I mean, here we might just say, adding 4 each time. Right, we can't really, we don't get a number set that counts by 4 starting at 13. Okay, do we get the idea here of how this is making us talk about what's reasonable and what's not? Okay. We're gonna look at one more in our notes. Is it okay if I turn the page?
13.
Do what?
How did we get the 13?
I plugged in one flower. Okay, and where I got that, Kaylee, wasn't just randomly. I went to what was the smallest input value I could give it. The smallest input value I could give it is 1. When I plug in 1, I get out 13. Okay? We feel okay with that? This should be quizzes. It needs to be something shorter. I can grade 5 quizzes every 17 minutes. Now, there is nothing that says you have to write a function rule for a problem like this. Nothing. But when we are talking about a reasonable domain and or range, we need to know what our x value is and we need to know what our y value is. So option A, you could just think in your head. What am I going to be counting by? What am I going to be plugging in? Sometimes that works great. The per flower example, usually my students have no problem knowing what my x value is. This situation gets a little bit more tricky. Okay? And sometimes you just have to be a little bit more specific because how you think about it could be different than how someone else thinks about it. Usually how I think about it is different than how my students think about it because I'm the one actually doing the grading. And so maybe you just have to be a little bit more specific of labeling what you want your domain and range to be. Okay? But if we look at this, usually a good starting point is for my students to think about this as a table or as a graph. One or the other. Create another option other than the word problem. Okay, write a function rule. You could. Sometimes my students struggle with that, especially when it's sort of this situation, but create another way of representing this as your starting point. That's usually a good way to help you think about what's a reasonable domain and range. And really the more important part is thinking about which is your x and which is your y. Anybody have some initial thoughts on what their x value would be? Brayden?
5. Right?
No, you're actually giving me a number. What are our unknowns in this? Like, we need a label. Like, is time our x value or is quizzes our x value?
Quizzes are your
Time.
no.
Time. Because
Time is
x
your
is
x
a
value.
dependent
'Cause
variable.
time is
No,
not-
independent.
Ah! What is time? Time is our independent variable. So if we were graphing this, what would we put down here?
Time.
Time. And what would we put here?
Quizzes.
Quizzes. So what's our x value? Time. What's our y value?
Quizzes.
Quizzes. Okay, that's a way to help you think about what you want to be your domain and what you want to be your range. Okay, so our domain is going to be time. Okay, so what's a reasonable amount of time that Mrs. McKinney could work? How long could I spend grading? Could I spend 0 minutes grading?
No.
Yes. Sorry guys, I'm not going to grade them. I mean, it's probably not a good option as a teacher, but I could. You probably have some teachers who have made that choice in the past.
Yep.
Could I spend 10 minutes grading? Could I spend 100 minutes grading?
Yeah.
Could I spend
The rest of your life.
5,000 minutes grading? Yeah, I could. Probably also not a healthy choice for me, but I could. Okay. So, can I spend negative 50 minutes grading? No. So if I'm talking about a reasonable domain, I'm talking about my domain, what are reasonable numbers for my time to be?
1 and up. 0 and up.
0 and up, right? So greater than or equal to 0? What's another way that I could talk about numbers that are greater than or equal to 0?
Rash.
We have to be a little bit careful.
Numbers.
So you would have to say, well, then you're not counting the decimals in between.
Oh.
So you'd have to say like positive rationals.
Well, I mean, it could be a decimal, right? Because it's not.
Right, because I could work for 4.2 minutes. That would be okay.
You could grade for.
So, right, in this situation, this tends to be the representation we see more because it can be the decimals and fractions in between, whereas our last representation, the natural numbers, tends to be what we see more. I'm not going to be so picky about that. I just want to make sure you know what's actually reasonable. Like I said, this isn't even like graded on your test in that regard. I want you to just be able to think logically about it. Okay, so then what would be reasonable for our range? For our y values. So what does y represent?
Quizzes.
My number of quizzes. Now, let's say I'm just grading quizzes maybe for my students. Would it be reasonable to say that I could grade 5 million quizzes?
No.
No, because I don't have 5 million quizzes to grade. But if we're just talking big picture, is it possible that I could grade 5 million quizzes in my lifetime? Okay, yes. So sometimes it depends on what like restrictions you're given. We're going to talk about that in just a minute here too. But so what is it reasonable for y to be? How many quizzes can I grade?
How
So
many
at least
students you have?
one, right?
One?
Well, I don't know that. No information up here is that given to me of how many students I have or anything like that. Right? So anything greater than or equal to 0?
Wait, so what's the point of 5 quizzes every 17 minutes?
Yeah, what is the point of that?
That's your.
I mean, right? If I really wanted to then find out how many quizzes I was grading and write a function rule with it, I would need it.
I made like a little table down here. I kind of erased it because I thought it wouldn't work, but I put, okay, yeah.
So like if 17 minutes have passed, I will have graded 5 quizzes.
Yeah.
Right, and that would help us write a function rule. But does this problem ask us to necessarily write a function rule? No. So does that 5 per 17 matter in that regard? No, it's just helping us decide what's x and what's y. Do we sort of see how this works?
So all we need to write for that was just the domain array, basically.
Yeah, this is what we're focusing on for now. Now, eventually, we're going to get to the point that we should be able to read something like this, write the function rule from it, talk about the important pieces from it, know what's a reasonable domain and range, know what that looks like in a graph. Okay, but we're not there yet. Yep, sure can. Because that's real world. Last one, and this looks totally different, and then we're going to do some practice here. I'm going to give you a different representation this time. This representation, because I can't graph a perfect circle, so bear with me. I'm going to put that point's at 5. You don't need to make a perfect graph, just make lines and know it's at 5. And then don't laugh too much at my circle. I'm really bad at it. Oh, that's one of my better ones. I know, it's still bad, but we're just going with it.
Wait, how are we going to write this down?
Just draw a circle. I know that there are 5s. Right, give yourself this in your notes. There we go, something like that. You don't need anything major. We're going to talk about when we look at a graph what's reasonable and unreasonable. Actually, what's actually right and what's wrong. What's possible. Okay, so this is more about what's correct than what's reasonable. Because we don't have a reasonable situation, we just have what actually works and what doesn't work. So domain, again, what is domain? X values. So when we're talking about x values, we are talking about this axis right here, right? This is our x-axis. We want to know where the graph exists with values on the x-axis. And my students really struggle with this because they forget, for example, pretend this point is perfect here. If It's not. But this is the point, -1, positive 4.9. There was a y value that went with that x value. Right? This is the point, -2, positive 4.6. There was an x value that went with the y value. So any place that we can find an x with a y counts as the domain. Here is the best way I've found for my students to sort of understand this. Imagine if you could take this graph and squish it. Squish it, squish it, squish it, squish it, squish it, squish it. Where on the x-axis is my graph going to end up touching?
So it's gonna be a
Right? Will it be touching here?
no.
Yes.
If I squish this, does this fold down and touch here?
I mean, not really. You're striking it. It's not like if you're holding it.
Do you mean the points or like?
Yeah, I'm confused.
Okay, let me draw these two lines here. Let me try again. Remember when we did compound and and or, and we imagined the graph sort of falling?
Oh, yeah.
Okay, imagine this falling down and this falling up. If you could. Falling up? Yeah, that is not. Rising. It's got helium in it. Where will this line touch here?
Oh, well, that X.
Yeah.
Do you see that better?
Yeah.
Do you agree that it will touch in all this space in between -5 and +5? How do we write these values?
0.
Well, they're both on the x-axis. Oh, on one.
Oh, really?
Doesn't that look just like our compound and inequalities? Oh, cool, Mrs. McKinney, it does all come together. You don't seem near as excited as I am.
No, we're so excited.
I'm so confused.
What are you confused about?
How did it make the compound with both?
It's in between -5 and 5. Compound and is our in between.
Wait.
I mean, it makes sense, but I'm not gonna
Yeah.
You will.
Still kind of hurts.
Okay, so now let's go the other way. And now you have to imagine falling left and right. Because now we want to do our range. It's like a weird vacuum that's pulling you. It's a windy day or something. I don't know.
It's a windy day.
I don't know. I'm making up random crap. Imagine this kind of going in here because now we want the y-axis.
Why was that so funny?
I'm a funny person.
It's like the pictures on my picture roll when I use my blood dryer. What?
Okay, so this is falling in here. Where gets touched on the y-axis?
Anything
Everywhere.
horizontal.
All that in between space?
Yep.
So that's now in between -5 and 5 again. Except what letter do I want to use this time?
Why?
Y?
Wait, why would it be less than or equal to on both of them?
Well, remember, if y was really first, this would really be
Oh,
greater
yeah.
than or equal to. It's compound and it's in between.